Hey folks, Quill18 here, and welcome to another episode of our Project MightySpud. This is our Unity series where we are trying to build a terrain-generating engine for an entire planet. And we have done some excellent work so far, but there's still a couple issues, certainly in here. Now, one of them is that if you zoom into certain places, there is a slight seam in between some of our terrain chunks. And there's two different reasons why that is likely happening. But one of the two reasons is most likely the most obvious one, so we're going to deal with that one first. If we go and zoom out, what I've done here, so these are still individual little terrain chunks, but we were working on like a 3x3 area. Here what I've done is I've set up so that we have 20 rows here, because what it's going to do a very good job of is demonstrating one of the issues we are still having. What is going on over here? Well, if you look at our test topography, actually I have it open in Photoshop. I have this black square down in one corner, in the bottom left corner of our image. And that is basically the North Pole. I mean, really, literally the entirety of the bottom of this slice is the North Pole, right? The very bottom of this image is entirely the North Pole, you know, divide by zero kind of error kind of situation. Okay? Now, that black square is what these notches are, right? It's clearly going down because black is lower altitude here, whereas the brighter the color gets is the higher altitude. So these little divots in here are that black square, just distorted because of the projection that's going on. These are correct, but why are there three of them, and why are they slightly tilted? Well, really, when you think about it, it makes perfect sense. If we come up over here, this is our equator, right? And let's say we start from this middle chunk over here. If I take this middle chunk and say, say, we're going to travel directly south from here. What does directly south from this chunk mean? Well, directly south means eventually we will hit the South Pole. Okay, and then if I'm over here on the right-hand side chunk, and I go straight down, what am I going to do? Well, eventually I'm going to hit the South Pole. And this is true from all of these places. No matter where you start, if you end up moving directly south, you will eventually hit the South Pole, which is why these are correct, even though they're clearly not correct. So we have to do some more adjustments. But the reason that that is happening, why we've got the trio of South Poles over there, is because right now we are just treating, we've got the one origin point, right? In our code, our dynamic terrain master, where we generate all the chunks, we always start our rotation from our origin, this landing spot, and then rotate away from there. But basically what we're doing, effectively, you can think of it as we are rotating to the right and then to the south. Or, you know, so to the east and then to the south, or west and to the south. Well, if we're always going to the south, then we'll always end up at the South Pole. So to correct that, we can't just keep looping, or we can't keep using the origin as the source. And we knew that going into it. I knew that was going to be an issue, but what it meant is it was just a really easy way for us to set up the initial grid of, like, we're going to make this many terrain chunks, and they'll look mostly okay. But we're going to go for more okay this time around. I will point out one of the ideas I had between episodes. By the way, I recorded the last episode 3 or 4 days ago, but I didn't want to put it up right away until I thought about this next section a little bit more and got this done, because I wanted to make sure that I was sort of on the right track here. I did actually go and do a test in our dynamic terrain chunk over here. We have this code here where we are doing kind of a micro rotation. Base X pause and Y pause is a value from 0 to 1, but describes our position in the current terrain chunk. So an X pause of 0 means we're on the left edge of the current terrain chunk, and an X pause of 1 means we're on the right edge of the terrain chunk. And we sort of know how many degrees of latitude and longitude each chunk represents, so we can do this tiny little rotation and then turn that into a UV coordinate so that we know what pixel from our terrain height map to read from, right? And I thought, well, could you do something similar? Could we figure out, I mean, we know where our world position is of this chunk, right? We are at, say, you know, some degrees. We're like this one here. We're at 512 coordinates, like positive X and negative 5,000 negative Y. Can we use that, you know, just add to our current X pause plus, you know, something like transform.position.x. We have to convert it from Unity space to like that 0 to 1 kind of space. But, you know, could we just do something like that? And yeah, you can. And actually, it leads to very, 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 very seamless content. But the problem is, if you do anything like that, then once again, you end up with your with the wrong projection, and you end up with terrain that looks very much like our topographical map, where everything is stretched at the bottom, instead of the correct thing that we're doing now, where things are not being stretched at the bottom. We get a tiny bit of pinching effect. Again, I'm convinced it's just a side effect of this particular texture that we're using. We'll see if we can find one with a better projection at some point, but I'm going to keep working with this one because why not? So there's a tiny bit of an odd pinching that happens, but it even happens in our sphere, so that's not our problem. But this duplication, we definitely have to go and fix. And so the point being that we really have to look at that local area kind of situation, right? We have to say, we have to render relative to some chunk, not the origin chunk all the time, because then weirdness happens. You have to say, like, when we're going to render this chunk here, right? This one right over here. When we render this one, the position of this chunk has to be based really sort of kind of on its neighbors. But here's what I propose, right? Here's what I propose. Let's make this a nice square little image. Right, the idea from the start, well, not literally from the start, but the idea for quite some time now, has been something like this, where we're going to have that kind of nine slice situation, right? So we've got, this is the area, these are all the chunks we're going to generate, and we're actually going to have a 3x3 area, so we're going to have 9 of them. The player is going to be sitting in here, right? And then all the other chunks are going to be rendered relative to that, which is sort of kind of what's going on in the middle. But even in the middle, we actually end up with a bit of a seam that wouldn't be ideal. You know, if we look between the 5 and the 6, like even here, you can see that there's a slight set of seams between these. And that's because the distortions are there. We're treating these areas as kind of a little bit more square than they necessarily are. But I think there's going to be 2 parts to the solution, as I said at the beginning of the video. And one part of it will be to get these two to be a bit more aware of each other and their corners. And that way they will be using, assuming we can do it right and figure out a solution, they will be coordinating to make sure that they are using the same pixels for that line in the middle, and balance things out a little bit more. But that's going to be something for later. What we're going to do first, though, is we are going to change this sort of rendering thing so that instead of always in our terrain master resetting the rotation to the landing spot and moving relative to that, we are going to make sure that we are just moving relative to our more whatever, I don't know, the neighbor. We're never more than one chunk away. Although again, you got to figure out like, well, what we gotta write our walking code, basically. That's what we have to do. Because it never makes sense, as we talked about before in some of our drawings, you can easily end up in a situation where if you're trying to render too many chunks that from like the point of view of the character, as you walk around, you'll end up with overlapping chunks that represent not the right thing. So I think that's what we're going to have to do. And here's what I would like to do, I think, as our test, as our simulator. I want to render this 9 slice. Okay, then instead of walking, what I want to do is have a button that I can hit that says, okay, so we were in the central chunk, right? So this is our landing spot here. We're going to render these 9, and then I want to push a button and says, okay, my character has now moved to here. Okay, I'm realizing my stuff's not square, but these are supposed to be square. There we go, more like that. Okay, my character's moved from here to here. And what I want to do is delete these chunks and create a new set of chunks over here. And most notably is I want these things to be rendered kind of based on our new movement over here, such that if we keep pushing the button over and over and over again, at some point we will end up at the South Pole, you know, so we've walked this way, and at some point we're going to end up such that the South Pole is, say, here, right? And there's still going to be that like weird little wedgie graphic thing, which basically will point to the South Pole, assuming we've done everything right. But that over here, it's not going to have a South Pole. In fact, think about the way this works, is at this point, this is going to be pointing north. And this will also be pointing north, and so on and so forth, but different chunks of north. And so we can confirm that by saying, okay, over here, this is going to be our 0 degrees longitude, and over here, we're actually going to be at 90 degrees east right? And over here, we're going to be at 90 degrees west, is the idea. And any one of those directions we leave and go north. And then assuming we followed one of those, eventually we'd actually hit the North Pole. So that's what we're going to sort of set up as a bit of a test here. And I think the easy part will be the plus shape. Like, I'm not sure exactly how to handle the corners, but the plus shape is really easy to figure out. Because for each one of these, right, we just say, okay, we can figure out the central chunk. Each one of our individual chunks look fine as far as I can tell, right? And this way, well, then we're just rotating by however many degrees each chunk is. Right now we're still playing around with like 10-degree chunks, so it's fine. So this is going to be 10 degrees rotated around the y-axis. This is going to be 10 degrees negative y-axis, 10 degrees positive or negative x-axis, whichever one it is, and so on like that. So that's going to be fine. The question becomes this chunk here. Do you just rotate like both like that? But I'm worried that's not going to lead to the correct solution. Maybe it will. Well, it must, because at the equator it looks fine. And again, what we're basically doing with the math is just always turning this to the equator. As long as these new chunks that we add on are based on this and not something that's like miles and miles away above, I think we're going to be okay. Again, there are slight inaccuracies and distortions along each one of these borders, but as long as each one of these shifts is small enough, then it's all going to like come out in the wash and hopefully be okay. Hopefully. God. All right. So again, I spent like 10 minutes not really writing code here, but I think we're all right. So we're going to go back to this sort of 3x3 grid, but I'm not sure that building it this way is correct. Is the problem. I think we might actually have something like build row, and then maybe like even a direction, right? Bool, so positive x or something like that, or maybe just a float, x direction, which defaults to a value of 1 or something like that. So as you move, if you move past the y boundary at the bottom, yeah, I guess we're talking about rows. These are in the y direction. So when you leave your middle chunk via the y boundary at the bottom, we're going to call build row to build a new row beneath us. Let's do that. Most likely what we're going to do is we're going to generalize this code. But let's imagine that situation, okay? So what we're going to do is our build from landing spot, we're going to go and, I guess I'll leave these values in here because we might tune them. But basically what we're going to do is create the center chunk. So create the center chunk. So we're going to do that first. So our rotation for our center chunk is just going to be based on the landing spot. That's fine. Our position is going to be, I guess one of the questions is the 0, 0, 0 world space. Should it be at the center of the initial chunk? Probably. So our position should still be something like something like, yeah, just give it a little, like a half of the world chunk size that way. Right? So if our chunks are 1,024 characters in size, both in width and height, basically, then we are going to go negative 512 on the X and negative 512 in the Z before plopping it down. That way, the middle of the terrain will be at the 0, 0, 0 coordinates in the world. It seems totally reasonable, so that's okay. And then what we're going to do is we're going to call this here, and we're going to do our central chunk is what we're doing first. And that's at x and y is equal to 1. Because our x and y in our 3x3 area here, yeah, so I'm hard coding in a value that might not be good. But for now, let's leave that in there. it'll make it easier to develop or to like build right now. We get one working case and then we generalize it is the way I tend to do with things. And I think it's a really good approach because it reduces the chance that you make some sort of stupid math error in determining your position or some damn thing like that. So right now, what we're going to do is we will just hard code in this 1, 1 value, and then we'll generalize it later on. So we're going to build a chunk in the center because these, again, they go from x equals 0 through to x equals 2. So it goes 0, 1, 2. So the 1 and 1, that's the middle spot over there. So we're going to generate that terrain chunk there. Then what we're going to do is we're going to call build the row below us. So we're just going to manually call build row, and we'll go ahead and give the y direction equals 1. It's possible that the this will be the row above us as opposed to below us, but we'll adjust something. Maybe we'll just adjust the comment. I don't know. All right, so we're going to do that. So the idea being, I think build row should actually have something like a terrain chunk. So it should have a dynamic terrain chunk, like root. This is the root object that we're going to use for this new row. So we should actually pass that in here. So in other words, we're going to pass this center chunk like that. Okay, so pass the center chunk, and then we're going to tell it to build a row in a certain direction. So for this, what we're going to do is we'll do a for loop, which is going to loop in the x starting at 0 with the max equal to num columns. Yep. So we're going to do that. And then this is going to create 3 chunks that is going to be just below our root chunk to start off with. So with these, again, the middle point of the plus is easy. I guess the question becomes this. For the corner parts, do you just rotate this one this way from the center? Right? So those are the possibilities. I'm trying to figure out what arrow I can undo here. There we go. So to calculate the position of this one, do you start from the middle one and rotate it in both angles at the same time? Or do you go to here and then rotate this way? Right? If we do that, then this edge will be more accurate and less distorty, but this one here will be more so. So I think the correct thing to do is to still use the origin and go here. You're sort of splitting the difference between some of the distortions. We can also try to figure out like better ways to handle it. But again, we're gonna, when we rebuild our chunks, right? We've got that rebuild chunk command here, which currently just sets up neighbors, right? But the other thing it's gonna have to do, then I moved my cursor, to do, this is where we want to potentially hint at chunks to eliminate seams in some way. I still don't 100% know that, but there's going to be something like that. I think it's going to be very simple in the end. But we're going to be okay. And I think the simple part in the end will be to make sure that when we create these chunks, we're just going to communicate at all 4 corners of these chunks. We're going to tell them what their, maybe what their latitude and longitude is, or their rotation, the rotation of each one of these, because you can use a lerp to go from one to another quaternion. It's actually a slurp, but I think we're going to be fine. We can have it go that way and use that as calculations or something of that nature. We'll figure something out there. But that'll be for another time. So yeah, I think we'll just do that, which should keep this a little simpler. So what we want to do here is say what? So our rotation, right? We are going to use the root position. Actually, so we don't need to do spherical to rotation because we can just get the root objects the root object, which is a dynamic terrain chunk, which has its chunk rotation value. So we're going to start there, but then we're going to take it and we are going to multiply it by a new rotation. We'll use Euler angles here. And we are going to rotate based on, in the x direction, it's going to be degrees per chunk. So it's going to be negative because we're moving, hold on. Degrees per chunk multiplied by x minus 1. There we go. Again, we're hard coding some stuff in. This one part is, we're just assuming hard coding based on the number of rows and columns, right? So what this will do is when x is equal to 1, we're going to be rotating by -1 degrees. When x is equal to 1, which is in the center column, we're going to be rotating by 0 degrees, right? Because this is going to be x minus 1. The 1 minus 1 is 0. Degrees per chunk times 0 is 0, so we're not going to be rotating. And then when x is equal to 2, which is the right side, then we're going to be rotating by positive degrees. Again, it's possible that some of these, the direction might be inverted here. I might be getting that wrong. We are going to do the same thing in the y direction, but for this, we're just going to use this y dir parameter, and then we don't rotate in the z. I think that's okay. And then the position, so vector 3, position is going to be equal to the root.transform.position. But then it's going to get changed up by new vector 3, where we're going to move in the x direction by, what's it called? What do we call it? World units per chunks. World units per chunk multiplied by x minus 1. World units per chunk multiplied by y direction. No. The y component in our unity world space is actually going to be 0. We're not going to move vertically, right? This would be vertical movement. But there we go. We use that y dir, but it's actually z dir, but different coordinate systems. Okay, so we've got this. So now we're setting a new position. So what we're going to do is we're now going to generate a new terrain chunk at, well, the x is going to be x. The y part is actually going to be minus 1. No, it's going to be 1 plus y dir. Again, lots of hard coding here, but you got to remember, so if y dir is equal to positive 1, then this will actually be a 2, so that's below us. And if y dir is equal to negative 1, then this will be a 0, so it'll be above us, or vice versa. Again, one of these signs is almost certainly inverted. But there we go. So what we should end up with now is one chunk in the center and then the row below or above it in some fashion. So we got to kill the program. And apparently we're doing a float to int conversion. Right. Actually, just make this an int. I think that is entirely reasonable. Okay, hit play. Okay. Oh, we ended up doing the same chunk twice. Also, we're going to null reference exception somewhere. Oh, when we're looping through everything, because we actually have a bunch of nulls in here. I think this is okay. What I think I'm going to do here is just comment this out for now. And that's going to be fine. Okay. Yeah, okay. So if it's doing that, this is an x. I was thinking we'd do a sign inversion, but it feels like we're doing an x and y inversion here. Is that possible? Oh, yes. These rotation has to be inverted here. Because remember, rotation through the x-axis or around the x-axis is actually rotating up and down, right? Again, if you hold your fingers, like put your index fingers together touching and hold them out in front of you, like so they're horizontal, they're flat. Well, if you twist your wrists at this point so that your index fingers stay horizontal, what you're doing there is you're doing a rotation through the x-axis. But what it'll do to the world is tip it up and down. So there we go. We need an inversion of the rotation code here. That's that. It might not be all there is to it, but that's a thing. There we go. Okay. So we got that. We can see, though, things are not actually lining up. But that's a problem for another time. One microstep at a time. I think this is generally going to be better. So if I do this, okay, I want to go in the opposite direction here, though. So, like, I want to set this as a -1. So now we're actually going to be going below us. So if I were to repeat this step, let's say I don't write train chunks. Okay, so let's you know what? Here's what I'm going to do. I like it. Let me get rid of this comment. I'm just going to skip the rebuild chunks command for now. Rebuild chunks, what it does is it tells the train chunks who their neighbors are, so that they it just affects level of detail, apparently. We're going to leave that out. We're not actually going to care about writing to the array at all. Right? Because we can still build chunks, so we're not actually writing anything to the array except for the original root bit. Right? But let's say after we build a row, testing recur num is equal to what we're working with. Well, actually, 10 in this direction would be fine. Okay? I'm just going to set this value here. So what I'm going to do is loop through everything in this row. But then after it's done, if x is equal to 1, testing only. If x is equal to 1, so if we're in the center column, then what we're going to do is we're going to call build row again. So if x is equal to 1 and testing recur number is greater than 0, then the first thing we're going to do is decrement the recursion number. But then, yeah, we're going to call build row again with this current chunk. Dynamic terrain chunk DTC is equal to this. So if we're in the middle column, then we're going to call build row again with this new DTC, and we're going to continue in the same direction as ydir. So what this is going to do is it's going to repeat this process 10 times, adding 10 extra rows to it, and it should hit us at the South Pole. And we're going to see exactly what kind of nonsense we're creating here. Okay, it will take longer, certainly, because there's a lot more chunks to do. So the big question is, yeah, only one South Pole. Yes! Yes, making a new note here, huge success. Only one South Pole, and again, if we leave from here, what we're actually doing is we're heading north. And if we're going this way, we're heading north, and if we're heading this way, we're heading north, out of the South Pole. There's still that slight offset, and the seams aren't quite working out right. But I think that's a contrast between the sort of circular projection and the flat projection. And there's a couple of different ways to tune it. It might simply involve a slight. This is in our dynamic terrain chunk code, right? This bit of code here, where we're sort of doing this local rotation, we might have to do. The solution might be a little bit of a tweak to this formula here, or there's a couple other things, but again, that's going to be next time. But the important thing here is that what we have just simulated is the idea that our character started right here, and that our character walked south, and walked south until the character reached the South Pole, and from here can leave in any direction. Technically, all of those directions are in fact north, but this build row code that we've got, we could, build row, build column, exactly like that. And we'll put in a little bit more logic for how it works. But now we could leave to the right and keep spawning things over there. And technically, as we walk away from here, we do need to despawn this stuff, because, again, a very important point is if I go walk here, and then walk this way, and then walk here, I'm not going to end up at the same place that you would expect. Like, this terrain is no longer valid if we walk along that path, because we are walking along something that's on a curved surface. Therefore, you can't map it on a flat surface. That's the whole point of this whole exercise, is your spherical planet cannot be mapped to a 2D surface as a complete thing. But this is working for a direction, so that's hopefully good so far. Notice like how straight this line is too, right? It's this little thing is straight here. Why is that? Again, because what we've done, we've started. It gets very clear actually if we zoom out once more and check the origin, right? We set our landing point to right here. Notice that this is the E letter here, right? And what we've done is we landed here and then walked directly south. And as you walk directly south, you'll eventually hit this, and it makes sense. This should be a perfectly straight line at that point. And that's what happens if you walk south from there. And keep in mind, yeah, it's mostly okay. It's not perfect, though. Well, again, okay, it's not perfect in that if instead of walking down here, we're walking south from here, right? This is the equator. We're walking parallel to the equator south over here, which means if we're heading directly, quote unquote, south, then we should hit the South Pole here, but we're not. And that's okay-ish. But in practice, the idea being that what this would actually do, this would be a much smaller set. Like our 9 slice would actually just be, say, this area. So we would start here, we'd go this way, generating some 9 slices, and then from here we would start walking down south, generating terrain, generating terrain, and what we would end up with is we would indeed eventually hit the South Pole right over here, walking directly parallel to the equator, assuming we do everything right. And I think we're mostly there. Again, there's still this weird distortion between things, which does become a lot less obvious if we are going with lesser to smaller sizes, right? Which, again, the smaller each individual chunk, the less we're going to fall victim to this distortion. The reason that leaving over here on, like right of the E and going south doesn't end us up at exactly the South Pole is because our chunks are larger and we're fudging more of this, right? Again, we're trying to map a circular surface onto a flat one, and so going parallel to the equator here and going south doesn't actually land us at the South Pole. And the degree of imprecision is entirely a side effect of the size of our chunks. Although what's funny is if we left from here and did travel east enough to generate some chunks over here, and then walked south from these chunks, which were not based on this origin bit, right? The idea being is whichever chunk the character just left, that's going to be or whichever chunk the character just entered is going to be used as the origin for everything else. So if we were here, and then we walked west and entered this chunk, we would generate 3 more chunks over here based on this as the origin, as the whole point. So if you were to walk here, even with these oversized chunks, if we walk here and arrived over here and then headed south, we would end up close to the South Pole. Again, at the very worst, we'd be, this far away from the South Pole. That's the worst case scenario, walking south from the equator because of the size of the chunks. But as the chunks get smaller and smaller, the error of margin that you could possibly end up from the true South Pole becomes incredibly minute. And then it's like you're never going to tell because it's just terrain or whatever. You're going to adjust yourself. You're heading on your compass. So that's going to be fine. Okay. I'm feeling all right. I don't think because I was really worried we'd get to a certain point where it just wouldn't work, and I'd be like, I've done this all entirely wrong. I'll never be able to solve this problem. I'm a huge disaster. There's still, I'm sure, there's a lot to figure out still, and I'm sure there's still a couple things I'm doing wrong. But we are, oh my god, we're so damn close. I really love the fact that these are 2 separate chunks over here, and yet you still have this really nice, like, parallel line over here. Because this is the prime meridian, and the prime meridian here is completely straight. It's just all the other meridians are coming off on these crazy-ass angles, and in fact can be represented by sort of a curving sort of thing, right? Because they're going to leave here in some direction, but ultimately they end up entirely parallel to the equator. So clearly there's this curvature. And that's why with the larger the chunk, the more that curvature is apparent. And whereas when you're small, just like when you're standing on the surface of the Earth, you can't tell that the Earth is curved because on small scales, it's, close enough to flat that it doesn't really matter. We're so close. Thanks for watching. See you next time. Thank you to all our February Patreon supporters, including these Mic Check supporters. We've got Yukofin, Snoopy, TRB, Pavel Zdanov, Drazian, Gavin Power, Jan Torivel, Michael McClintock, Aaron Toyvson, Craig Mortel, the not-so-evil engineer, Julien Auger-Lafont, Maris Fieldvold, Speedysant, Steven Stager, Valiant Cake Fiend, Wes Olenboiving, Jason Yanity, Stephen Bonnerman, Kale the Quick, Neil, Blakey, Milner, and absolutely everyone who's watched, shared, favorited, and subscribed. Thank you so much for making this possible.